Hey guys, welcome back. In yesterday's video, we covered the bond seesaw in relation to what you need to know to pass the Series 65 exam. And I want to do a follow-on topic today, a related topic covering discounted cash flow, what you need to know about DCF to pass the Series 65 test. The Series 65 is a 3-hour exam which seeks to qualify candidates as investment advisor representatives. 3 hours for 130 questions. You have to get a 71% basically to pass, 92 out of 130, and the test costs $187 each time you attempt to take it. So we want to see you pass on the first try. And in order to do that, I recommend signing up for a website like Achievable here that I have on the screen. There is a link down in the video description. Achievable has all of the materials you need if you properly use it to pass your Series 65 on the first try. Highly recommended by me. A couple of other facts about the Series 65. It doesn't have any prerequisites, and you do not need to be employed or sponsored by a FINRA member firm in order to register or take the exam. If maybe you just want to improve your education, improve your understanding of the markets, or maybe, down the road, you want to become a investment advisor representative. Either way, just for education or for future potential job use, it's a handy exam to take to test your knowledge. With that little introduction out of the way, let's get right into the topic of today's video, discounted cash flow. On my channel, we sometimes use DCF to calculate the fair value of a bond or a stock, and it is a widely misunderstood topic, and we're not going to go into the full DCF model in this video because you don't need to know all of that to pass the Series 65. We're going to just basically talk about this formula and a couple of high-level topics that you are going to need to understand conceptually in order to properly answer the questions. And I'll show you some sample test questions at the end of this video. So stick with me just a couple minutes, whether you're taking the Series 65 or you just want to learn the basics of DCF. Let's run through a couple of slides here. The Series 65, as I said, is not a math exam. It's going to focus on conceptual understanding and practical application of discounted cash flow rather than any complex computations. You do need to memorize this formula and understand it, though. You will need to be able to use it, but you're not going to be doing 5-year DCF models in the Series 65. You should be able to calculate the present value of future cash flows using a discount rate such as the cost of capital. Apply DCF to bonds, stocks, or other investments by discounting expected future cash flows. Understand the concept of net present value and internal rate of return. I think we'll save that for the next video. And the final bullet point here, you should recognize how changes in discount rates or cash flow projections affect a security's valuation. There are some basic concepts and definitions that you must understand in order to answer questions on the Series 65 exam related to DCF. We're going to start with, what is the definition of discounted cash flow? It is the value of future cash flows in today's dollars adjusted by a discount rate to reflect their present worth. What is a discount rate then? It is the interest rate used to adjust future cash flows to their present value, reflecting the time value of money and risk. Present value simply is the value of future cash flows in today's dollars, and opportunity cost. There will likely be questions on what is opportunity cost or opportunity risk. Opportunity cost is measuring the lost returns from a missed investment opportunity. If you chose an investment that returned 7% in 1 year and you decided not to choose another one that day, and that investment earned 17% over the next year, you had an opportunity cost. You missed out on 17%. You only got 7% because you picked option A. Your opportunity cost was 10%. Breaking down the DCF formula to its basic components, we have PV equals FV over 1 plus DR to the nth power. That is, the present value equals the future value over 1 plus the discount rate, and the nth power would be the number of years. We're going to go through a whole series of sample test questions at the end of this video, but just to kind of set the stage here, here is a sample to think about using the DCF formula. What is the present value of a $1,000 par treasury bill set to mature in exactly 1 year, assuming the average rate of return in the market is 5%? We're going to use this formula and the information in the question to fill out the variables, and you'll have a basic calculator just like this where you can then compute the answer. Looking at our formula, the future value is $1,000. That is what the treasury bill is going to pay in 1 year. And the average rate of return on the market is 5%. That's going to be our discount rate. We want to know what is today's value of that treasury bill. So we have 1,000 over 1 plus 0.5. And it says in the question here, it matures in exactly 1 year. So it's just to the power of 1. Using our calculator, then it's very easy. We have 1,000 divided by 1.05, and that gives us our answer, 952.38. That simple question gives us a flavor of how to do this for a T-bill that expires in 12 months. But what if we're looking at a bond that has a maturity greater than 12 months? And so one other sample question just to think about the concept of DCF. Remember, we're not trying to become a math expert per se to pass this test, but you must understand the concepts. We have a question that says, an investor is considering the purchase of a $1,000 par 2-year 5% corporate debenture currently trading at 97. The rate of return in the market is 6%. What is the present value of the debenture? And considering this question, there are a couple of things we need to think about. The first of all is we have multiple years in this example, and then we need to identify what is the future value in year 1. Year 1, we're only looking at the coupon payment. In year 2, we get an additional coupon payment plus maturity at par value. So we have one calculation to do for year 1 and another calculation to do for year 2. Our coupon payment is going to be 5%, it says, of $1,000. So $50 for year 1 and $50 for year 2. The discount rate we have given to us in the question, where it says that the rate of return in the market is 6%. Putting all of those together, you could then calculate the present value of the coupon for year 1 and the present value of the coupon plus the maturity of the bond in year 2. Then you have to add those two results together. So at the bottom it says our total present value is the sum of our year 1 present value plus our year 2 present value. Again, think of the concepts here. What do you need to know in order to calculate the present value of a bond? You need to know what is the bond's par value. You need to know how many years. You need to know, if you're calculating a coupon, what is the coupon rate, 5% here. And you need to know the rate of return in the market so that you can calculate your discount rate. If those pieces of information are available, then you can calculate the present value of a bond. You're probably not going to need to do a complicated math equation, but understand what components are required to calculate the present value of a bond. That is the key thing that I want you to keep in mind. We've gone through the formula. Present value equals future value over 1 plus the discount rate to the nth power. You must memorize this formula. Probably want to jot it down on your scratch paper that they give you before you start taking the exam, because you're not going to be able to take any notes in with you. Make sure you commit this to memory and make sure you understand what these concepts are before you go sit down and take the test. Discounted cash flow, discount rate, present value, and opportunity cost. A final concept that falls under the DCF umbrella that there will probably be some questions on the Series 65 for you would be understanding the difference between an annuity versus a lump sum payment and how to calculate which one might be a better option to choose if you had to pick between an annuity versus a lump sum. Think of if you won the lottery. You know how those lottery winnings work. Let's say you won $100 million. You get a choice when you take your ticket in. You get to have payments come to you annually, $100 million divided by 30 years, one payment per year. Or they might say, you can pick that, the annuity, annual payments, or we could give you $50 million today, and that is your lump sum payment. It is a reduced amount paid immediately. And you can use the discounted cash flow model to calculate which one of those might be a better decision for you using a given discount rate. It's not likely that you're going to need to run the math on a question like this, but you must understand the concepts because it's common to get a question about annuities versus lump sum analysis. Let's move on to some sample test questions regarding this material. And one thing that I love about Achievable is as you finish each little chapter, you immediately get a little quiz to make sure that you understood the material that you just read. It'll be followed up at a later point with a much longer practice exam simulating going into the testing lab, doing your 130 questions in 3 hours. But you could take these quick quizzes, and then if you didn't understand something, go back and study the material again, take another quiz until that information is locked in your brain. Question number 1 here, which of the following statements is correct regarding the treatment of annuity payments in a lottery payout analysis? Select the correct one. Each annuity payment is counted at face value in the comparison. Number 2, annuity payments are tax exempt and therefore not included in calculations. Number 3, annuity payments are typically discounted back to their present value using a chosen discount rate. And number 4, annuity payments increase in value over time due to inflation. If you see a question like this, remember annuity versus lump sum. I want you to think discounted cash flow, discounting future values back to present value. So it's going to be number 3. Annuity payments are typically discounted back to their present value using a chosen discount rate. We'll hit confirm. If that is correct, it'll turn green. And yes, that one we did get correct. Number 2, all of the following are components required to determine a bond's present value, except, remember that math example I showed you with the 2-year bond, and we needed to calculate the coupon for year 1 and the coupon plus maturity in year 2. I want you to think what material was in the question that allowed us to fill in the formula. Here in this question, we have 4 things to choose from. Which one is not needed? The choices are interest payments, the bond's market price, the time to maturity, and the discount rate. We do need to know the interest payments because we need to figure out what is the value of the coupon versus the par value. Remember when we calculated in year 1 the present value of the coupon, you got to know the interest payment to calculate what that coupon is worth. You must know the time to maturity so that you can fill in the small n on the bottom of your math formula. And you must know the discount rate as well, which is on the bottom side of your formula. We do not need to know the bond's market price. So yes, that is correct. Number 3, what is the present value of a $1,000 par treasury bill set to mature in exactly 1 year, assuming the average rate of return in the market is 5%. Although you can't bring any notes or other materials with you, you will have access from the testing center to a basic calculator, addition, subtraction, multiply, divide. And that's all we need to figure out this question. What is the present value of a $1,000 par treasury bill set to mature in 1 year? That makes it easy, assuming the average rate of return in the market is 5%. Remember, you must have your present value formula memorized. That is the future value over 1 plus the discount rate to the power of the number of years, which in this case, according to the question, is 1. So that makes it very easy. We have the future value on top, 1,000, divided by 1 plus the discount rate which would be 1 plus 0.05, 5%, and $952.38 is what we're going to pick as our present value of this treasury bill. That is correct. Number 4, which of the following factors may influence an individual's decision when evaluating lump sum and annuity lottery payout options? Another question on that annuity versus lump sum concept. What do we need to think about when we're trying to decide between which one of those to pick? Potential investment returns. If you got all of the money today, what rate could you invest it at? Inflation and taxes. How is the value of today's dollars going to be degraded over time? Or the value of annuity payments degraded over time due to inflation and taxes. Present value of future cash flows. We know that is going to be there for sure, because in order to calculate the present value of the annuity payments, we know we need to run the PV formula. Really, you need all 3 of these. So I'm going to select all of the above, and yes, that is correct. In order to decide between a lump sum and an annuity, all of these factors might influence your decision. Moving on to question number 5, securities analysts utilize present value to determine the investment worthiness of various securities. Yes. Which of the following statements best describes present value? That was in one of the first slides that I presented to you guys in the definitions. What is present value? Is it total assets minus total liabilities? Is it the sum of discounted present day cash flows? Is it the market price of a security? Or is it the value of future cash flows in today's dollars? I don't know about you guys, but I think it is the last one. And yes. Now let's move on to the final question in this little quiz. An investor is analyzing 2 securities for investment. The first is a 30-year mortgage bond that will yield 8% to maturity. The second is a value company stock, which pays a current dividend rate of 3%. They decide to purchase the 30-year mortgage bond. That's paying 8%, all right? Several years later, the investor determines the stock would have resulted in a total annualized return of 13%. Oops, made the wrong decision. Should have gone with the stock. You would have got 13% instead of 8%. It says, based on the scenario, which of the following is most applicable? Discounted cash flow, reinvestment risk, interest rate risk, or opportunity cost? Again, reflect back to the definitions I gave you guys at the beginning of this presentation, and this is a question relating to opportunity cost. If you had picked the mortgage bond at 8%, you would have lost out on 5% versus if you had picked the stock. Now, you don't know that until later when you see how the stock performed, but that cost you an opportunity cost of 5% on the potential return you could have earned. So we're going to pick opportunity cost. And yes, that is correct. That is all I've got for you today regarding understanding the concepts of discounted cash flow and the present value formula in terms of what you need to know to pass the Series 65 on your first try. In the next video, we're going to take this to its next logical step and talk about some additional concepts related to DCF and present value. And that would be the NPV, the net present value, and the IRR, which is the internal rate of return, just covering the basic concepts of what you need to know to pass these Series 65 tests. So if you have any questions about DCF or the present value calculation, leave me your comments or questions below. And I hope to see you on tomorrow's video where we talk about NPV and IRR. I am Tony Denaro. Thank you for watching, and I will see you on the next video.